discuss about the OSI model and layer explanations. In this video, you are going to see about the layer 1 physical layer, and layer 2 data link layer, and layer 3 network layer, layer 4 transport layer, and layer 5 session layer, and presentation layer and application layers, and the comparing the layers and OSI models in practice, and benefits and limitations of the OSI model, and at the end conclusions. The introduction part is the overview of OSI model. The OSI model is known as Open System Interconnection. Model is a conceptual framework used to understand and describe the network communication systems. It consists of 7 layers, each with specific functions that enable communication between devices and networks. Layered architecture. The OSI model follows a layered architecture where each layer focuses on specific tasks and interacts with adjacent layers to facilitate the flow of data through a network. This approach enables interoperability and modularity in network protocols and technologies. And the third, the layer communication. At each layer of the OSI model, data is encompassed with headends information, and the communication process is coordinated with the corresponding layer at the receiver end, and this ensures that data is transmitted, received, and interpreted correctly across networks. The layer 1, the physical layer. Physical layer functions. The physical layer is responsible for transmitting raw data bits over a physical medium such as cable or wireless signal. It manages the hardware aspects of data transmit and reception, including signal encoding, modulation, and line coding. The second one, the data transmission. Physical layer handles the transfer of digital data between devices and networks. It defines the electrical, mechanical, and functional characteristics of the interface and the runnalism medium, ensuring reliable, efficient data transfer. The cable type and signal encoding. Different types of cables such as twisted pair, fiber optic, and coaxial are used for data transmission signal encoding techniques such as NRZ, non-return to zero, and mechanism according encoding ensure proper representation of data on the transmission medium. In the layer 2, data link layer. The data link layer responsibilities. The data link layer provides reliability data transfer across the physical networks. It facilitates framing, error detection, and flow control to ensure accurate and efficient data transmission. It also manages access to the physical medium. And the framing and error detection. The data link layer frames data into packets and adds necessary control information for error detection and correction. It verifies the integrity of data frames and retransmits erroneous frames to ensure reliable communication. And the MAC address and access control. Each device on a network is assigned as a unique MAC media access control addressed by the data link layer. This address is used for addressing and identification, enabling devices to communicate within the network. The layer 3, network layer. The network layer functions are: the network layer is responsibility for logical addressing, routing, and packetting forwarding in a network. It enables host-to-host communication and determines the optimal path for data transmission, routing, and IP addressing. Network layer defines the routing protocols and manages the assignment of IP Internet Protocol addressing to device. It ensures that data packets reach their intended destination by forwarding them through interconnected networks. And the packet forwarding and network topologies. Data packets are forwarded by router based on network topology and routing tables. The network layer optimizes packet delivery and resolves network configuration through efficient packet forwarding mechanism. The layer 4, transport layer. Transport layer objectives are: The transport layer provides end-to-end communication and ensures reliable data delivery between source and destination. It segments and reassembles data, manages flow control, and supports error detection and recovery. And the reliable data delivery. A transport layer establishes reliable data transfer by acknowledging received data, retransmitting lost segments, and ensuring the correct sequencing of data packets. This enhances the integrity and completeness of transmitted information. Then the flow control and port numbers. Flow control mechanism regulates the data flow between senders and receivers to prevent congestions and data loss. Port number enable the identification of digital different communication channels within a single network interface. And the layer 5 is a session layer. Session layer functions. The session layer establishes and manages communication sessions between devices. It initiates, maintains, and terminates sessions, ensuring synchronized data exchange and coordinates between applications. The establishment and managing connections. Session layer coordinates the establishment, maintenance, and termination of connections between communicating devices. It manages sessions token to authenticate and authorize the communication participation, and the session tokens and resynchronization. Session token are used to validate session participants and manage session state information. The session layer supports session resynchronization in case of communication disruptions. And the layer 6, presentation layer. Presentation layer objectives are the presentation layer focus on data representation, encryption, and transformation for network communication. It prepares data for transmission by encrypting, compressing, and converting it to a suitable format. Data encryption and decryption prevents presentation layer secures data by encryption it from the transmission and decryption it up to reception. This ensures data configuration and integrity during communication. Data compression and conversion. The presentation layer optimizes data transmission by compressing data for efficient storage and transmission. It also facilitates the conversion of data formats for interoperability between different systems. And the layer 7, it is the last layer, application layer. Application layer functions. The application layer provides network services and interface to end user applications. It supports protocol interaction, API usage, and the presentation of user interfaces for application functionalities. And the protocols and APIs. Application layer defines application protocols for specific network services and utilizes APIs for communication with the lower layer protocols. It enables seamless integration of application functionality with network communication and users interfaces and network services. The application layer presents user interfaces and application service to end users. And the comparing the layers, the comparing functions and protocols. Layer function comparison. Each layer of the OSI model performs distinct functions that contribute to the end-to-end communication process. Comparing the layers highlights their unique responsibility and interaction in network communication. And protocols usage and interactions. Different protocols are associated with each layer and they interact to facilitate data exchange and communication services. Understanding the protocols at each layer supports effective network troubleshooting and optimization. Interlayer communications. The interaction between adjacent layer and protocol ensures seamless data transfer and communication services. Interlayer communication is essential for maintaining the integrity and efficiency of network operations. OSI model in practice. The practical application of OSI model are the OSI model guides the design and implement of network equipments, protocols and communication standards in real world networking scenarios. It serves as a reference framework for understanding and optimizing network infrastructure. The network equipment interactions, network devices such as router, switches and firewalls interacts based on the principle on the OSI model. Understanding these interacts helps in configuration, troubleshooting and securing the network equipments. Protocol mapping and data exchange. Mapping specific protocols to OSI layer enhances the understanding of data exchange and communication process. It provides a foundation for protocol analysis, optimization and compatibility assessment. The benefits and limitations of the OSI model. The benefits of OSI model are: the OSI model provides a standardized framework for network design, troubleshooting and protocol integration. It enhances interoperability, facilities modular development and support comprehensive network understanding. And the limitations of OSI model are the rigidity of the OSI model, layered structures and the potential for protocol overlaps are considered limitations. Additionally, the model may not account for the complement of modern network technologies and dynamic communication environment. And at the end of the video, the conclusion of the key insights, summary of the OSI model and layers. Key insights are the understanding the OSI model and its layer structure provides valuable insights into network communication, protocol interactions and data exchange process. It supports comprehensive network troubleshooting and optimization strategies. And summary of OSI model and layers. The OSI model with its 7 layers offers a comprehensive framework for understanding network communication systems. Each layer plays a unique role in enabling data transfer, communication service and end-to-end connectivities. Thank you. If you like the video, please like, share.